is we're still going to take our polynomial. Today they're going to give us terms to divide by or zeros to divide by. Your job, and I say it, your job is to always to make sure that you're dividing by the zero of whatever term you're given. For example, in this case here, I'm going to divide x cubed by plus 2x squared minus 6x minus 9 divided by x minus 2. X minus 2 is a term, therefore what's its zero?
2.
Good. So that's what I mean by always dividing by the zero of a term. We're going to go back and forth between terms and zeros a lot from basically the next couple of sections. So if you remember from synthetic division, not only was it quick, but it was just working with coefficients. There's my 0, 1, 2, negative 6, negative 9. What was the first step for synthetic? Do you remember? Drop the 1 down. Good. Then what? Multiply. Then what? Add. Then what? And that's how you would synthetically divide. Now, since that one did not end up with a 0, that meant that the negative 5 would be a remainder, if you will. So each time that you are dividing out, if you divide x cubed, 2x squared, whatever, by the x minus 2, you wind up with x squared plus 4x plus 2 minus 5 over x minus 2. Notice how it just drops it a degree, and all of these numbers are the coefficients of the new polynomial.
What?
That's so much easier. It is. It is. Okay? But we're dividing by a singular term. The term has to have a degree of 1. Okay? Yes, ma'am?
So why is it 5 over x minus 2?
This is the remainder. If you remember when you divided out long form before, let's see, 147 divided by 2, you get 7, 14, bless you. 2 goes into 7 3 times. You have 1,
Yeah.
so it was 1 half.
Oh, okay.
It's the same basic principle, but you're dealing with a polynomial. Sir?
If you had a degree of 2, could you make that into 2 individual terms and then use
If it's factorable, yes. And we'll get to that over the next couple of sections, okay? So in this case, if I divide the x cubed and all that junk by the term x minus 2, I use the 0, and I'm left with that. I had a remainder, so could I factor out an x minus 2? No, because there's a remainder, so it's not a factor. Okay, it's not divisible by x minus 2. There it is.
So did you just divide everything by x minus 2?
Yep.
But how'd you get, okay, if it's x cubed and then you divide it by x minus 2, why is it just x squared when it be
How do you
like-
turn an x into an x cubed?
Well, I know, I get that part, but it's minus 2. So wouldn't it be x squared over negative 2?
No, what's happening here is I'm using the 0 of that term to go into the coefficients. Okay? You're hung up on the long division right now. This is a much simpler way. Let me show it again with the plus 3, okay? I do the same thing with the plus 3, x plus 3. If I'm going to use x plus 3 as my term, what would be my 0? Negative 3. So I have negative 3, 1, 2, negative 6, negative 9. Using synthetic division, the first step is always to drop the first term, multiply and add, multiply and add. Oh, got ahead of myself there. And I get 0 at the end. Since I got a 0 at the end, that meant there was no remainder, which means it's a factor of it, which means that x plus 3 is a factor of x cubed plus 2x squared minus 6x minus 9. So since this is a 0, this had a term of x plus 3 And now I'm left with x squared minus 1x minus 3. I was able to factor out an x plus 3. This is how you factor things that you can't factor by grouping, if you want to think of it that way. Remember how we did that earlier? If you had 4 terms, you try to get GCFs and things like that?
Yeah.
This is how you do it if that doesn't work. What do you say?
Wait, why do you factor x plus 3 out when you go through your trying to divide?
Well, that's what we are doing. When you're factoring something, aren't you dividing it out? Same idea.
So, even for normal,
Yep.
and then we have to go to the quarter, this is the same thing for the division.
Yeah. And this is still, eventually this is how we're going to factor everything. Because we're going to be able to factor a 6th, 7th degree polynomial using synthetic division real quick. Sir?
So like, are we gonna get like higher degrees?
Yeah. Yeah. I'm going to show you an example of that here in a little bit. It's very, once you get the hang of what everything means, it's so quick, it's so fast to go through. I'll show you another way. So if we use synthetic again, we'll do these separately. I'm going to take x cubed minus 8x plus 3. I'm going to divide it by x plus 3. What do you have to have? A placeholder. Very good. Is your head feeling better today? Okay. I'm sorry, I didn't say anything. Well, I know I'm fine, but I need to.
It's really Mr. Murphy?
Why not?
All right.
I'm hungry.
Doesn't.
I chicken.
I know, I'm eating chicken right now. I'm looking forward to chicken. So when I go through this one, what's the 0 of the term x plus 3?
Minus -3.
Minus 3, negative 3, either one's okay. Throw your terms in, you have 1, 0, negative 8, and 3. Biggest mistake you're going to do when you're writing these things out, you'll forget a placeholder and or you'll forget to put the negative sign in.
That's what I think.
I've done this once or twice, you think? Drop and go. Hey, hey, look at that. It's a 0, which means you can factor it out. So you have now x plus 3 times x squared minus 3x plus 1.
Oh my gosh, this is easy.
Now, at this point here, could I factor that further?
Yeah.
What times what's 1 you add together to get negative 3? Nothing.
Wait.
Negative 2.
Negative 2.
Negative 2 times negative 1 is
Negative
positive 2.
Yeah, you're right.
So we'll just say no.
So wasn't this A for the other one where you're studying it like this and then factoring it out?
Pretty much. And check this. If you wind up with a 0, that means it's a factor. It means then it wasn't a factor. I was just showing you what it would wind up to have a remainder. That's it. We'll get there. That's all right. Yes, sir.
What was the thing you did where you're like able to get all the possible zeros?
I'm going to show you that in a little bit. Yes, sir.
So what's the 1, negative 3, 1, so what's the 0? The 1?
The 0 means there's no remainder.
So like, wouldn't the 1 be the x cubed?
Nope, because remember, this every time you synthetically divide, you drop a degree. Think about what this means. I divided something out, so I FOIL this in, and we get x cubed when I multiply it, won't I? So you're taking terms out. Yeah. Okay. Let's try the other one. Let me just do this. Easy. X to the 4th minus 16x squared plus x plus 4. So it's a 4th degree polynomial, which means how many terms should it have? 5. Does it? No. Who knows? What do you need? 3. You need a 0 for the x cubed. Very good. If my term is x plus 4, what's my 0? Negative 4. Good. So then you go through 1, 0, negative 16, 1, and 4. Drop the first term and go.
Yay!
Yes, I did right.
I did something.
Oh, that's negatives.
Yes, ma'am.
Are you gonna do it where not the part that you're dividing, but the x to 4, are you gonna make it like x squared plus 2x plus 4?
No, not yet. We're not worried about it yet.
Not for a while.
Don't worry about it. Okay. Most of these things, in order to synthetically divide, you gotta have that singular degree. It's gotta be able to find 0.
Okay.
So now that means, yes,
So, on a quiz, when it says to factor, and we did this, we can still factor it further. Do you want us to factor it further?
I'm getting to that. Because now, this is what you probably see this right now, is that you've got x plus 4, then we have x cubed minus 4x squared plus 1. Can I factor x cubed minus 4x squared plus 1 by our normal? No, I really can't. Now, there will be a time when I'm going to say find all real solutions, find all solutions. So there will, as we get into this over the course of the next few days, we'll show you other methods to continue on factoring that, to get the imaginary solutions, to find those other roots that are there. All right. For right now, we're just starting with this. All right. Okay. Same idea. Now they're going to say factor the polynomial. So they say factor it, which means factor it all the way you can, as far as you can go. Find all the terms. And this is a very easy way to do this because, well, first of all, look at your starting polynomial. You've got 2x cubed plus 11x squared plus 18x plus 9. It's a cubic polynomial with 4 terms, which would normally lend itself to trying to group it. You guys remember that from a little while ago?
Yep.
If I group that and try to go GCFs, it's not going to work. So what they're doing here is telling you that, hey, one of your zeros is at negative 3. So if negative 3 is one of your zeros, what's one of the terms that you could factor out of it?
X plus 3.
X plus 3, very good. So they're giving you a 0 to start with, and then you have to work your way out. So in this section, they're going to tell you where to start. They're going to say f of negative 3 is a 0. So negative 3 is a 0. It's going to go into 2, 11, 18, and 9. Drop and go. It better be a 0 because it told you it was going to be a 0. If it doesn't work out to be a 0 and they told you it was a 0, you done goofed. So
Are you sure the
ungoof
book
it.
wasn't lying to me? I don't trust the book.
Okay. So minus 1 is the 0. Your term is, not minus 1, excuse me. Minus 3 is your 0. Term is x plus 3. And now you're at 2x squared plus 5x plus 3. And it's asking you to factor this further. What times what is 6? You add together to get 5.
3 and 2.
3 and 2. So you factor this trinomial by grouping. 2 times 3.
I get it.
And you factor that trinomial via grouping. Take your GCF. So you have 3 terms now. X plus 3 from what we already found. X plus 1. And 2x plus 3. So you factor that fully which means you have 3 possible zeros, because third degree polynomial, you can have up to and including 3 zeros. One of them we already knew it was at. Where's the other one? Okay, so you've got 3 zeros, -3, -1, and -3 halves. What are the tails dancing? Down up. Yeah.
This is gonna cover so much.
But it's all the same thing.
Wait, did we take a quiz?
You're just adding numbers.
Okay. So this isn't any, what we're doing here is, like you were asking, can we go further? Yeah. Synthetic division allows you to get to those other parts. But you're lucky in this unit, they're going to tell you where to start. And I'll show you in a little bit here what you do if you don't. Here's another way that they're going to write it. In this sentence, they wrote it as, yes, sir?
Does what is it, synthetic division work for polynomials of the second degree? No?
Yeah, it's just, but when you have polynomials of second degree, it's usually a lot quicker just to go right into multiply your tails to add in the middle. But it does work. And there will be times that, as we get into this, you're going to have multiplicities sometimes. And as you go through synthetic division, you guys have noticed hopefully by now that it is real fast. I hope. Maybe. Or am I just hoping that you notice that? Okay, so anyway, what will happen is when we start factoring these a little bit further, we get going to the more complicated version of it, you're always going to double check for multiplicity at the same value, and it will work. But here they wrote it as 1 0 of the function blah 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 is x equals 2. So what's the 0? 2. What's the term?
-2.
Good. Synthetic and go. Yay, it was a 0. Yay, we ended at 0. That's correct. So 2 is our 0. So our term was x minus 2. Now I'm left with, I went down a degree, x squared minus 9. Where are my other 2 zeros? Plus minus 3. Yes, sir.
No, if you're trying to find the zeros, you don't need to factor that out the rest of the way. But if it asks you to factor it out, then you should.
It's really weird. All right, let me show you what happens. Oh, you can't figure out what was there. Let me show you what happens if you don't know a starting point. Yes, I know, thanks. So if I'm going to start with this one, I've got x cubed minus 8x squared plus 4x plus 48. What we're going to start with on Thursday is how do we take this when we don't know our initial 0? There's a way of finding them. It's called the rational root theorem. It's a whole lot of words for what are all of the factors of the constant divided by all the factors of the leading term coefficient. Let me say that again. What are all the factors?
That's a lot of factors.
Of the constant over the factors of the leading coefficient. Then it's plus minus. Because you can have 1 and 48, -1, -48, and so on. So what are your factors of 48?
1, 2, 3, 4, 6, 8.
You skip 12, 24.
Oh, 16.
Yeah, I thought there was 16. 16, 24, and it's plus minus. All divided by 1. So we have, yes ma'am?
Wait, so the constant is the last number
Yeah,
without an x?
yeah, the last number is the constant, and the leading term coefficient is this.
Okay.
So that means we have, ready, let's count them. 1 little, 2 little, 3 little zeros, 4 little, 5 little, 6 little zeros, 7 little, 8 little, 9 little zeros, 10 times 2 is 20. Thank you. There are 20 possible zeros here. And is there any rhyme or reason of where to start about looking for zeros?
Nope.
No. Obviously, yes, that's the easiest way if they tell you where to start at. But what I'm getting at here is I'm trying to show you guys that sometimes people we're asking third hour, can I just guess and check? That's fine if you want to, no big deal. But I always say start with 1 and work your way through it. Have an eraser. Synthetic division is quick, and you should be able to anticipate that a number is or is not going to work pretty quickly. For example, let's start with 1. And we had, what was it? 1. Oh!
Hey,
Cooper.
that's your stuff. You moved your desk, you idiot.
Why are you getting it? Idiot! I'm taking my stuff.
So, like I said, before we were rudely interrupted, you might be able to notice that synthetic division is real fast. And then we get what, -3? It's not going to work, is it? I'm not going to get 0 at the end.
Oh, erase it.
If I put -3, you're going to get not 0. I erase it and I go to -1.
When you do that in pen.
That's a mistake. Why would you ever do math?
This
in
is,
pen?
I do math in pen all the time, but this is the time that I use a pencil. Yes, sir.
Is there a way to like, oh wait, I guess, never mind. We're not gonna help you guys.
Go to 2.
Please go to 4 again.
You can, but what if I don't give you those values? And what we got here, -12.
Really? I know that.
-2.
But I'm going through the motion. So
Mr. Murphy, you're Josh, you also have to be faster.
This is the fastest way to do it. Oh no, it took me 4 tries to synthetically divide to find a 0.
What if it takes you 20 though?
It takes no, what'll happen?
Or whatever, 10 or 8 or whatever.
It normally doesn't. It really doesn't. I honestly believe that the most, okay, I shouldn't say that. If you go through 8 or 9 of them and you haven't found something yet, you probably screwed up somewhere, okay? And that happens because, the book told us what was a 0, but I found one at -2, didn't I? Yes, sir.
Would you just work your way backwards?
It doesn't matter where you start.
On the right side of this one, so like,
Right. It doesn't matter.
like, you know that in order to get 0, you're gonna have to subtract 48. So what times 4 is gonna give you negative? I just kind of work.
You can do that if you want. I'm just saying start at the beginning and work your way through. Synthetic division is real quick. Okay, if you want to sit there and think about it, go for it. I'm not. I'm just gonna do it and go. It's faster.
Alright, is there like, since it's -2 on the equation, it's in both, is there like always 2 of them? Or is there like 2 different ways to get 0, or is there only 1?
What do you mean?
Because it said on the equation that 4 was 1, that got
Yes.
to 0.
Yeah.
So there is there like always more than 1 of them?
Yeah, I'm showing you. Because now what happens here is I'm left with, I factored out an x plus 2. Now I have x squared minus 10x plus 24, which gives me a regular trinomial. What times what's 24 add together to get -10? -6, -4. Which gives me a total of 3 possible zeros at -2, 6, and lo and behold, 4, what they told us was to begin with. Now, let's say you got -2 and you screwed up, and you didn't get a 0 at the end. Yes, ma'am?
Wait, so those are the only zeros?
Yep.
Right, so like you only have to find one of the zeros and then.
A lot of times. Unless it's a 5th degree polynomial, you might have to do it again. We'll get there, okay? Synthetic division might take a little bit of space on paper, but it is, I'm not lying to you, one of the easiest things that you're gonna do for factoring. It'll work, okay? Now, going back to the original problem, it said that 4 was a 0. Watch what happens if I would have used that 4. -1, 4, -4, -16, -12, -48, 0. Which gives me terms of x minus 4, x squared minus 4x minus 12. What times what's -12 you add together to get -4? -6 and +2?
Factoring.
And don't I get the same thing in different orders? Yeah. So if you do mess up, so if you're like Mr. Williams and he messed up with his negative earlier, he didn't get a 0 here, so you just went, dang, blasted, and you went through a couple more tries and you got to 4 and you made it work, you're still going to get there. You can still get there, even if you do make a mistake.
I'm confused. So the first thing we did was you're just showing us that we just go through it, right?
Yeah.
But you to find all zeros, you can just do that, right? So in what case would we do this if we weren't given a zero?
Yes.
Oh.
Yeah, because I'm showing you what we're going to be working on more Thursday. It's the same thing that you're doing now, but now they're giving you a term or giving you a 0 to start with. Thursday, you have to start making the lists yourself. So as you, like I said, as you go through these things, you're going to get to stuff that you're going to be able to factor, and then you're also going to get to stuff that you're not going to be able to factor. You might have to use the quadratic formula. You're going to have irrational roots. It happens, but it's all going to get us there. Okay? Yes, ma'am. No. No, and you can actually synthetically divide with imaginary roots as well. And we do that at pre-calc. We might do a little bit here. I haven't decided yet. Yeah, and it's actually really easy. They're really easy to work with. A lot of the fraction stuff you get in with these things, as you're getting your zeros out, you wind up with like an even numbers, and they simplify out real fast. They do. You have trust me. Okay, sir.
If you include the fraction, isn't every number theoretically?
Oh, nobody likes it.
Then how do you do that?
Careful.
Yes.
28 to 56, every other even. I think it's a whole lot of 8 of them or 9 of them.
Yeah, that really hurts.
Right? Same unit, should go put it right on there. I don't know if there's a lot of, you actually have to go through and factor everything. It's a little bit more of just getting accustomed to the process of it. We get into it more tomorrow, or excuse me, on Thursday. We'll talk more about listing rational zeros and going from there. It's good fun.
I'm doing math off of my phone because I got my computer taken away. Oh shoot, I have to write down my
Wait, that was every other even? Oh, yeah.
Add to it. Just add to it. You guys got a good 12 minutes. You should be able to get probably most of this stuff. No.
Second hour.
Yeah, I guess yesterday there was something wrong with the Google. I don't know what's going wrong with it. I guess Chrome, freshman Chromebooks don't like to go to YouTube anymore.